Teschler with Design World Magazine. I'm here with Mike Armentrout from Infineon. And Infineon has a way of encrypting IoT transmissions to keep out hackers, which Mike is going to talk to us a little bit about. So Mike, if I'm a hacker and I want to hack into, say, a camera in somebody's house, and it's not protected, what do I do?
So the first thing that an attacker will often do is go buy an example of the device. They'll go back to their home where it's a nice, secure environment for themselves, and do a physical attack onto the product. Go in, look and see how it's being, the encryption's being done, how the security's being handled, if there's any keys that are being used, and from there they're able to then devise a way to either make their own board look like that camera and then get into the network, be able to get further into the network, or be able to then use that to hack onto the camera and watch the video feed that the camera is recording.
So how do you get around that? How do you stop that?
So one way to get around it is a chip like we have here that we're demoing. This is our Apptiga Trust product. This is an authentication chip. It comes pre-programmed with all the security codes needed with the keys. And what this does is it allows the device manufacturer, the camera manufacturer, to put this chip onto their device, and then the camera is authenticated to the server so that the server that's looking at that camera knows this is not an attacker, this is a legitimate device, it's not counterfeit. And from there, they're also able to protect the user, that when the user logs on, they can authenticate the user and make sure that they do a positive matchup between the right user and the right camera so that no one else is looking at your video feed as well.
Mike, that sounds great, but if I'm a hacker, why can't I go buy one of your chips, a device that contains one, and reverse engineer it?
So one of the things that Infineon does is these are hardware security chips that are protected against physical attacks. So this is similar technology to what's used in the payment space on credit cards that are coming out now with the smart cards. That same type of technology we also use for IoT products, which means that we're not just protecting against a software attack, but we're also protecting against physical attacks that the attacker could be using.
I see. And just to be clear, we're showing this on a camera, but it doesn't have to be a camera, it's any kind of IoT
It could be used for absolutely anything, yeah. Any endpoint that's in a system that either you want to protect that device itself, or that you want to make sure that that doesn't become an entry point to the rest of the network.
Interesting. Yes. And how much does that add to the cost of something like a camera?
So we have multiple range of products, all the way from just very basic plug-and-play authentication chips up through fully programmable microcontrollers, which can do additional things such as secure updates, memory integrity checks of the system. But in all cases, you're going to be looking at under $2 for these types of devices.
Great. Well, we've got a little demo running here behind us. Can you take us through it?
Yeah, so this demo is showing the camera. This is a IP camera talking Wi-Fi through the router, then over to a server. And the idea here is that the server is able to validate that the code that's sitting on this camera is the legitimate code. It's doing an elliptic curve authentication to validate that what you're talking to here is the right camera. It's not, as I said, a counterfeit or a hacker trying to get on the system.
Interesting. Well, that's pretty cool technology, Mike. Thank you.
Thank you.